Welcome back everyone. So we are going to discuss the timers used in Atmel 328P microcontroller and how to write a program to use a timer interrupt to turn on and off an LED. We will be discussing here. So here I have given you a simple flow chart for this program. As usual, at the beginning we start the program, and at the beginning we have to configure the timer interrupts if we are going to use the timer interrupts, and then we are going to set our data direction for our LED. That is, a particular pin of a port should be set as output to connect the LED, and then we are going to stay in the never ending loop until we gets an interrupt. So if we get an interrupt, we will move into the interrupt, execute the interrupt service routine, and come back to our main loop and keep inside the loop. So in the interrupt service routine, we will be going into the service routine and then checking if the LED is on or off. If the LED is on, we will be setting it to off. If the LED is off, we will be setting it to on, and we will be exiting the interrupt service routine. As I said before, once it exit the interrupt service routine, it will be going back to the main loop and keep looping there. So that should be our program. It's a very simple program. So here the LED is supposed to turn on and off at successive timer interrupts. So we'll be looking into the timer interrupts available in Atmel 328P. There we have two timers, so one 8-bit timer and one 16-bit timer. So in each of these timers we have two interrupt modes. One is the timer overflow mode and the other one is the timer compare mode. So timer overflow mode is the interrupt which occurs when timer overflows. For example, with this 8-bit timer, we can count is up to 255. So once it comes to 255, and if it counts one more, it will overflow the timer. With that we can create an interrupt. If it is a 16-bit timer, we will have maximum counts of 2 to the power 16 minus 1, somewhere around 16,535 or something. And then once it reaches the maximum amount, if there is another clock pulse, then it will overflow the timer. We can create an interrupt when the timer overflows. Or else, with the timer compare interrupt, we have flexibility of generating the interrupt somewhere in the middle from 0 to that maximum time by comparing the counter value or the timer value with another compare register where we store the compare value. So here, for example, in this 8-bit timer, the maximum time duration for an interrupt is clock pulse duration into 2 to the power 8. So that will be our overflow interrupt, but in between we can have compare interrupts. For 16-bit timer as well, we can have compare interrupts in between 0 and 2 to the power 16 clock pulses, right? So now if our clock pulse is 1 over 16 megahertz. Now this Atmel 328P microcontroller we generally use in 16 megahertz. So 16 megahertz means our clock pulse is 1 over 16 million seconds, right? It's a very small duration. Now if we are going to use the 8-bit timer, what is our maximum duration for the interrupt? 1 over 2 to the power 16 into 256. That is a very small amount, right? 1 over 2 to the power 16 1 over 16 million into 256, right? That is 16 over 16 million. Sorry, 16 over 1 million, right? That is a very small number. Even if it is 16-bit timer, the maximum count that we can have is 2 to the power 16 divided by 2 to the power 16 into 2 to the power 16 into 1 over 16 million, right? 2 to the power 16 divided by 16 is 4096. That is 4096 divided by 16 million, sorry, 1 million, that is around 4 milliseconds, right? The maximum duration that we can have. So that is not going to be enough for our timer interrupts. Because of that, we are going to divide the clock by several factors and try to elongate our time. So that we call clock prescaling. So in this particular microcontroller, we have few prescaler values. No prescaling is 1, and we can have prescaling 8, prescaling 64, prescaling 256, or prescaling 1024. Now, if we prescale by, let's say, 256, that means my clock duration will be, what is applying to the timer will be 1 over 16 million into 256, right? So my clock pulse increases. When my clock pulse increases, my total duration that I can have from my timer will increase. So we will be going into it in a while, right? So now the settings that we are going to need when we are configuring a timer interrupt will be the mode of operation, whether it is going to be overflow mode or the compare mode, and then the prescaler, then time interrupt enabling, and if we are going to use the compare interrupt, then value for the compare interrupt register, and so on, right? So we will be discussing how to do those. So timer in a block diagram is something like this. So we have the main clock. Main clock is prescaled, that means clock is divided and applied to the timer counter or the timer register. So based on the clock pulse which is submitted to the timer, it will keep on increasing its count. When it keeps on increasing its count, if it overflows, it can create an overflow interrupt if overflow interrupt is enabled, and if the mode is selected as the overflow mode or the normal mode. Overflow mode is a normal mode. Or when the time keeps on increasing, if we have a value in the compare register, then this comparator will compare the two values, and if those two values match, it will generate a compare interrupt if the compare interrupt is enabled and the mode is set to the compare mode, and it will generate an interrupt. So that is how the timer will work, right? So here I am listing the settings required for each of these parameters. For example, for prescaler is set by TCCR1B register, right? So if it is, so now I'm discussing timer interrupt 1, right? That is why this one is TCCR1B. R1 is time interrupt 1. If it is time interrupt 0, this will be TCCR0B, right? And the time interrupt 1 is, so time interrupt 1's overflow interrupt is set by TIMSK, that is timer interrupt mask register, TIMSK 01 bit 0, right? At the same time, mode is set by TCCR1A bit 1 and 0 and TCCR1B bit 4 and 3. I'll discuss it in the next slide, right? Now here, now mode of operation, I'm going to discuss only two modes of operation here, the overflow mode and the compare mode. So this particular example that I'm discussing right now is using the compare mode. So the compare mode in the modes of operation is the CTC mode, right? In the CTC mode, my values for this WGM 13, 12, 11 and 10 should be 0, 1, 0, 0, right? So where are these bits? those bits are in this TCCR1A register and TCCR1B register. WGM 10 and 11 are here, these two are here, and the rest of the 2 bits 13 and 12 bits are here, right? I have to set these 2 to 0 and these 2 to 0 and 1, right, to set this to compare mode, right? Then I have to set the prescaler bits are TCCR1B, these 3 bits, right, these 3 bits. If my prescaler is, for example, let's say 8, prescale by 8, so my values for the prescaling bits will be 0, 1, 0. So I have to set these as 0, 1, 0. And if I am using timer compare interrupt, I have to enable either compare interrupt A or compare interrupt B, right? So there are 2 compare interrupts available with each of the timers. So here, if I consider timer interrupt 1 compare A interrupt, so I have to set this particular bit, right? If it is the B interrupt, it is this particular bit. So there's no difference between these two. You can choose either one. Or if I am using the overflow interrupt, I have to set this bit. But right now I'm going to use timer compare interrupt A. So for that I'm going to set this bit, right? And then the compare value I have to set in this register OCR1A H and OCR1AL. Now why do I have 2 registers here? That is because this is a 16-bit timer. I cannot write all 16 bits to the register at once. So register is divided into 2 8-bit registers. OCR1A is divided into 2 8-bit registers. The 8 MSBs are set at the OCR1AH, and the rest of the 8 least significant bits are set at OCR1AL register, right? So we'll be going into this as well when we are coding. Now the main problem here is to find out the prescaler value that what we are going to use, right? So here I'm listing prescaler, not the maximum durations that can be obtained by timer interrupt 1 from each of the prescalers. Now for example, now when the prescaler is 1, that means no prescaling, my maximum duration that I can have is the clock pulse duration into 2 to the power 16, that is 4.096 milliseconds, right? But if I prescale it by 8 times, my maximum duration will be 8 times than that, right? If I prescale by 64, my maximum duration will be 64 times than that. If I prescale by 256, my maximum time will be 256 times than that, right? Likewise, my maximum duration of the timer interrupt will increase when the prescaler value increases. So based on the prescaler value that I am choosing, I have to set these bits of TCCR1B register, right? In the TCCR1B register, I have to set the first 3 bits. So I am listing here. This is how we are going to set that. So if I am going to set last 3 bits to 0, 0, 1, this, so last bit will be 1, and the rest of the bits I am not going to change. Because of that, TCCR1B O equal to 0B, all zeros, and last one is 1, and I have to set these 2 to 0, because in order to do that, I am going to end with all ones other than these 2 bits. So all ones other than these 2 bits, and I am ending with it, right? So similarly, I can set any of the prescaler value by this method, right? So mode of operation, again I have discussed this. TCCR1A registers last 2 bits, and TCCR1B registers second and third bits. Sorry, TCCR1A registers TCCR1A registers last 2 bits, and TCCRB registers 1, 2, 0, 1, 2, third and fourth bits should be set for this, right? That is these 2 bits and these 2 bits. Now since I am going to set this to the compare mode, these two will be set to 0. So these two will be 0 and rest of the bits are 1. I am ending. So these two will be forced to 0, and if I have to set these two bits to 0 and 1, then I have to first AND this one 0, rest of the ones are 1. So this one 0, rest of the bits are 1, and then I have to set this one to 1. So I am ORing with O equal to this one is 1 and rest of the bits are 0, right. Now how do I set my prescaler? How do I select my prescaler? That depends on what is the duration of the timer interrupt that you require. Now let's say that you need a timer interrupt of 1 second. So if you need timer interrupt of 1 second, then you have to compare the maximum durations of each of the prescaler value that you are going to choose. If I choose prescaler value 1, the maximum duration that I can have is 4.096 milliseconds. If I choose prescaler value 8, I can have maximum of 32.768 milliseconds. This we have calculated before. If I have choose prescaler 64, I can have 262.144 milliseconds. If I have prescaler value 256, I can have maximum of duration 2.097152 seconds. Right? Those are calculated in here. Right? Now since I need 1 second of a timer interrupt, so I cannot have it using this one, I cannot have it using prescaler 8, I cannot have it using prescaler 64, but I can have it using prescaler 256 because the maximum duration is now more than 1 second. So I am going to choose the prescaler value 256. If I choose prescaler value 256, what should be my prescaler setting? So if I choose 256, my prescaler setting would be 256, prescaler setting would be 100, right. So 100 is set by TCCR1B, last two bits should be set to 0, rest of the bits I do not change when I am ending, and this bit should be set to 1, this bit should be set to 1, rest of the bits 0, I am ORing, right. So I am setting this to 100, right. So this is the setting. Now I have selected my prescaler. I am setting my prescaler using TCCR1B register, and then I have to enable my timer OC1EA bit of TIMSK timer interrupt mask register 1 for this one. So I am, so in fact this is not correct, this should be TMISK1 O equal to 0B 0000010, right. So this one should be, TMISK1 O equal to 0B 0000010, right. So not this one, so it should be this one. Now I have set my mode of operation to compare mode. I have set the prescaler value. I have enabled my timer interrupt compare register, so compare interrupt A, right. Now other than that, what I will have to do is to enable the global interrupt in order to configure my interrupt, right. So this part is completed, and then I have to set the data direction bit of my LED pin. So my LED is attached to port B pin 5, so I have to set it to output, and then that's all. And then inside the interrupt service routine, I will have to toggle my LED pin, right. For that I can use a variable, and if the variable is 1, I am going to set my LED to 1. If my variable is 0, I am going to set the LED to 0, and then I am going to toggle the value of the variable. That is how I am going to approach it, right. So here now I have enabled the interrupt here timsk1 o equal to 0b00000010, and then I have set the mode of operation to CTC, and then I have set my prescaler to 256, right. I have done all that. Now I have to set my compare register value. In order to have 1 second duration, how many clock pulses that I am going to need. Now if I go back to this, now I am comparing my timer register value with the compare register value, right. For these to be matched to 1 second, right, I have to have a certain values stored here corresponding to 1 second, and when this one will keep on increasing, it will increase up to that particular value, and if those two values match, it will generate the interrupt, right. So what is the value that I am going to set there? How am I going to select that value? What is my time interrupt duration that I am going to need? My time interrupt duration is what? My time interrupt duration is 1 second, right. So what is the clock pulse duration now? Clock pulse duration is 1 over 16 million into 256, right. So I am going to need number of pulses. 1 second is 1, divide by 1 over 16 million because of the 16 megahertz clock pulse duration, and this one prescaled by 256 means this one multiplied by 256, right. 256 into the clock pulse duration, and 1 over that is my count. So my count will be now 16 million should go up, so that is 1 million divided by 16, that is equal to 62,500. The answer is 62,500. So if I write this in hexadecimal, this will be 0xF424, right. So this should be the number of clock pulses that I am going to need for 1 second. So when the two values match, the value that I am storing is this one. When the counter matches this value, it will generate the interrupt, right. So this has to be stored in OCR1A high register and OCR1A low register. So the first value will be stored in the low register, this one. So that is 0x24 is stored in the lower register, and 0xF4 is stored in the upper register, right. But here's a small trick here. The value here is wrong by 1 count. Why? Because now when we generate an interrupt, until the two values, so if I go back to the block diagram, so when these two values match, until these two values match, you have, let's say if it is 62,500, if this value is set to 62,500, then the compare interrupt will generate the interrupt only when these two values match at 62,500, and for that interrupt to output, it needs another clock pulse, right. For that to output, it needs another clock pulse. Because of that, it will take 62,501 clock pulses to generate the interrupt. Because of that, always the value we store here will be one value or one clock pulse less than the amount that we are going to need for the timer interrupt. So if we need 62,500 pulses for the interrupt, the value we are going to save here is 62,499, that is 62,500 minus 1, right. So because of that, the actual value which should have been here in fact is 0xF4 0x23, but in this particular example it doesn't matter that much because we are not into strict time limits. But if we are into strict time limits, we have to make sure that we are gonna, the value that we are going to save is 1 less than the counts required for the time interrupt, right. Now we configure our time interrupt, and SCI is enabling the global interrupt. So we enable the global interrupt, and then we set the data direction for the port B. So I'm going to set most of these pins as output. So pin 5 is also an output. Now I have set the data direction of the pin as well, and I'm going to never ending while loop, and I'm going to stay in the never ending while loop until we get the interrupt. So when the interrupt occurs, we are going into the timer interrupt service routine. So timer interrupt 1 service routine, there are 3 service routines. Timer interrupt 1 overflow, timer interrupt 1 compare A, and timer interrupt 1 compare B. So here I'm going to use timer interrupt 1 compare A interrupt. So ISR is a keyword for Atmel Studio. ISR gives the interrupt service routine, and the particular interrupt is given by this particular vector name. These vector names are given in the datasheet and even in the IDE as well. So this is the particular vector, and inside that I'm gonna write my code. So here I'm using a variable named toggle. So if my toggle variable is 1, I'm gonna turn my LED on. So I'm turning my LED on by setting the pin 5 to 1, and if the toggle value is 0, I'm gonna turn the LED off. That being done by setting my pin 5 to low. So setting the pin 5 low is by ending with all ones other than that particular pin, and then I'm changing my toggle variables value. If it was 1, 1 minus 1 will become 0. If it was 0, 1 minus 0 will become 1, right? I'm toggling the value of my toggle variable, right? So this way, every time this comes in here, it will toggle the value of the output. That means it will toggle the status of the LED. Now there's something special about this toggle variable. This variable I have defined as volatile. So I could have just defined this as int toggle, but I have defined it as volatile int. So whenever we are using a variable inside the timer interrupt, it's better that we define it as volatile, because by defining this as volatile, it protects the variable from compiler optimization. Sometimes when compiler optimizes, it do various things like rather than reading the value directly from the particular memory location, it can keep a copy somewhere and read it from the memory, read it from that copy. So in that case, you won't get the actual value right at that point. So if we find that these variables are always changing, especially if they are using in interrupts, you never know when it is going to change. Because of that, these variables, it's better if you define as volatile, right? So that's why we define it as volatile. So if it is not used inside the variable, we could have just used int toggle equal to 0, but here I'm using volatile int toggle equal to 0. So the toggle value will be changing every time it goes into the time interrupt service routine. So this is our program, and we will see how it is being coded in Atmel Studio 7. So in Atmel Studio 7, I have set my clock speed to 16 megahertz, and by default it will give us this io.touch, which has the hardware definitions. Since we are using interrupt service routine for timer interrupt, I'm gonna use interrupt.touch as well, and then rest of the things I have already explained. So this timer interrupt compare vector, compare A vector, we are going to use for the interrupt service routine. Now if I show you this, see, you can see these interrupt vectors is listed here when I type half the name. So because of that, it's easier to find these interrupt vectors, right? So I'm going to use timer interrupt 1 compare A vector, right? So now I can build the program. So I'm going to rebuild it. So it will clear and build again, right? So let's wait until it builds. Now it is still building. Okay, build is successful, and we'll see if I can show you the Proteus simulation. Okay, this is the Proteus simulator, and I'm gonna go to that particular program. Okay, here it is, this interrupt. So it is the time right now. Okay, and then I'm going to run this and see if this LED blinks and changes its state every 1 second. Right, now we can see the time in here down below from here. Okay, I'll pause it when it changes its state. Right, now it's changes state at 9.3, changes its state at 10.3, right? So it is changing its state every second. So this is what I wanted to show you, how to create the timer interrupt using Atmel Studio 7 for Atmega 328P microcontroller. Here I have used timer interrupt 1 and the compare mode. So we have configured the interrupt, found out by finding out the prescaler and the compare register value, and enable the interrupt, enable the global interrupts, and program the interrupt service routine, and we have explained how it works. So thank you very much. So we will be meeting you with another video with a different aspect of Atmega 328P microcontroller and Atmel Studio 7. So thank you very much.